Here we have a performance problem. Reads, refer to figure 35. What is the expected fuel consumption for a 1,000 nautical mile flight under the following conditions? And they give us an altitude of 8,000 feet, temperature 22, manifold pressure 20.8, and wind calm. Looking at the table at the top, we can see that it tells us power settings required to achieve 65% power. Now, if you're at a high altitude, the airplane will not be able to produce 65% power. The throttle will be all the way in to full throttle, which is why these shaded areas here, we can see fuel consumption rate drops from 11.5 down. And the pilot will have to lean the mixture out to prevent it from becoming too rich. Anyways, so we can see the performance. When you select a power setting, it tells you for that altitude and temperature, your fuel flow performance, and your speed performance. And we will need those to solve this problem. When we're solving this problem, I like to create a couple triangles to organize my information. It'll look like this. We take ground speed, distance, time, gallons per hour, and gallons. They give us the distance is 1,000. I'll write that here. Nautical miles. Looking at the table, we can see we have a pressure altitude of 8,000 right here. And the temperature is 22 Celsius. Now, each of the three panels represents a different temperature range. So at 8,000 feet, you can see the temperature is -19 over here on the panel on the left, 2 in the middle panel, and 22 Celsius on the panel on the right. So we're not looking at the standard temperature or international standard atmosphere, -20, ISA, -20. We're looking at the panel of ISA plus 20. I can see the manifold pressure is 20.8, which is consistent. And we have a true speed of 164 knots. I'm going to write that right here. The wind's calm, so true air speed is also ground speed. Take a distance, you divide it by your speed, that gives you time. 6.1 hours. They also have a fuel flow of 11.5 gallons every hour. Take time, multiply it by 11.5 gallons every hour. That gives you your answer of 70.1 gallons. Answer Bravo is correct.